Hello and welcome to this video on series. We are given a series and we want to find the nth term and the nth partial sum of the series. Okay, so we're told that whenever we have an expression of the form a plus ar plus ar squared, and then we continue like that with a times powers of r, we have what we call a geometric series with the ratio r, and a is just a constant, and both a and r are fixed. We want to make a equal to 2 and r equal to 1/3 to see what we get, and then to find the nth term and the nth partial sum of the series. So when a equals 2 and r equals 1/3, what we get is a, that's 2, plus a times r, that's 2 times 1/3, so 2/3, and then a times r squared. Let's write some things here. 2 times r, that's 2/3. A times r squared is 2 times 1/3 square, and that's 2 times 1/9, because we get 1 squared over 3 squared, and that's 2/9. And we continue like that with terms of the form 2 divided by a power of 3, and the power is n minus 1. Or if we look at the formula for a times r to the n minus 1, we get twice 1/3 to the n minus 1, but 1/3 of the n minus 1 is 1 to the n minus 1 over 3 to the n minus 1, and any power of 1 gives us 1. When we multiply 1 by 2, we get 2. And then when we multiply 1 by 3 to the n minus 1, we get 3 to the n minus 1. Okay. So we have a series that looks like this, like the one we just wrote. And what we can say is that the first term of the series is 2. That's the first addend we see. The second term is the second addend we see, so that's 2/3. The third term is the third addend we see, and that's 2 divided by 9. And as we continue like that, we notice that the nth term, nth addend we see, is 2 divided by 3 to the n minus 1. So the nth term of the series is 2 divided by 3 to the n minus 1. And the nth term is usually denoted by a sub n. Okay. Right. Now that we have the nth term of the series, let's find the nth partial sum of the series. Remember that we have 2 plus 2/3 plus 2/9. The nth term of the series is 2 divided by 3 to the n minus 1. The first partial sum corresponds to the first term of the series. We take the first term of the series. The first partial sum is denoted by s sub 1. while the second partial sum corresponds to the addition of the first two terms of the series. So we take 2 and then we add 2/3. That's the second partial sum. The third partial sum corresponds to the addition of the first three terms of the series. So we take the first three addends and add them up. That's how we get the third partial sum. In general, to get the nth partial sum, we add the first n terms of the series. So we have the first one, the second one, the third one, and we continue like that until we add what we found was the nth term of the series, 2 over 3 to the n minus 1. That's the nth partial sum of the series. So in general, this is what we have. The nth partial sum of the series, that is a geometric series with a equals 2 and r equals 1/3, is given by this expression. We add 2 with 2/3 and then 2/9, and we continue like that until we go until we reach 2 over 3 to the n minus 1. And this would be enough. This is enough to find the nth partial sum. We have found the nth partial sum, and we have found the nth term of the series. But let's do a little bit of extra work and find a more explicit version for the nth partial sum of the series, and this is going to be helpful for later. So let's find a more explicit Sn. This isn't always possible, but this is possible for a geometric series. To find a more explicit Sn, we do the following. We say that we have Sn equals 2 plus 2/3 plus 2/9, and we continue like that until 2 over 3 to the n minus 1. If we multiply Sn by 1/3, that's the ratio, then we get 2/3 plus 2/9 plus 2 over 27, and in general we get 2 divided by, and 3 multiplied by 3 to the n minus 1 gives us 3 to the n. Then we see many things in common between Sn and 1/3 of Sn. Notice that 2/3 shows up both in Sn and in 1/3 of Sn. Same with 2/9. Same with many terms. Here, as we multiplied terms by 1/3, we found 2 over 3 to the n minus 1 in the process until we got to 2 over 3 to the n. This is really coming from multiplying, going a little bit backward in Sn, multiplying 2 over 3 to the n minus 2 by 1/3. That's how we get 2 over 3 to the n minus 1. So we were saying there are many things that Sn and 1/3 of Sn have in common. Then if we take 1/3 of Sn minus Sn, many terms cancel out, except for the 2. The 2 is part of the expression for Sn, but not for 1/3 of Sn. And this term 2 over 3 to the n is part of 1/3 of Sn, but not of S. So we get a lot of cancellations. We're left with 2 over 3 to the n minus 2. So 1/3 minus 1 times Sn is equal to 2. We can take 2 as a common factor, times 1 over 3 to the n minus 1. We can multiply both sides of the equation by -1 to get 1 minus 1/3 times Sn is equal to 2 times 1 minus 1 over 3 to the n. So Sn is equal to 2 times 1 minus 1 over 3 to the n, and then divided by 1 minus 1/3. This is the nth term, the nth partial sum, not the nth term, but the nth partial sum of the geometric series that comes from taking a equals 2 and r equals 1/3. Okay, so this is all for this problem. If you have questions, let me know, and I will try to help you. Bye-bye.